All right, so question number 1. What function is opposite over hypotenuse? Sine. So you can either write sine or you can use the abbreviation SIN for that first one. Now, number 2, you've got a little right triangle. It's special. It's a 30, 60, 90. And your job is to tell me how long that one side is. Just that one side there where the X is. That's a root 3 because root 3 is across from the 60. So that one is a root 3. Tangent. What over what? One acceptable answer would be opposite over adjacent. Anybody know the other acceptable answer? Y over X. That's exactly right.
Probably the same one for number 1 too then. Could you do the Y over R or the?
No, because that has one blank. That one's the name. That's not a fraction. But sine is Y over R.
Yeah.
That's exactly right.
So we're looking at that 30-60 triangle. Would the opposite be the straight line going up and down?
Well, it depends what angle you're looking at. This is opposite the 30, but it's adjacent to the 60. It's all about which angle you're looking at. Okay, what is the abbreviation for cosecant? CSC. The abbreviation is CSC. Now we've got another triangle, 45, 45, 90. And we want to know how long that side is, and it is, oh, my iPad just dropped over. No, I'll get it. Let's try not to bump the wall, guys. That would be the best thing to do. That's a theta. That's your angle. All right, that should stay up. Over here. All right, COT is the abbreviation for cotangent. So you need to write out the word cotangent. Now, number 7, this is a little application problem to see what you've figured out. And your job is to find the cosine of that angle. What is the cosine of that angle? What's cosine? Okay, so here's theta. Which side is the adjacent side? 4. Which side is the hypotenuse? 5. So what's the cosine? 4/5. Instead of letters this time, there are numbers. Cosine is adjacent over hypotenuse. And since the angle is right there, this is the adjacent. That, of course, is the hypotenuse. What is the reciprocal of the sine? The name of the function that is the reciprocal of the sine.
Hypotenuse over opposite.
Okay, what is the name of the function that is the reciprocal of the sine? Cosecant. It's the cosecant. The cosecant is the reciprocal of the sine. On your pink sheet, I have them lined up next to their reciprocals. So sine is lined up with cosecant, cosine is lined up with secant, tangent lined up with cotangent. Okay? When I want a fractional answer, I am going to try to eliminate, some of you have confusion, I'm going to try to eliminate it by setting up a fractional answer blank, like I did in problem 3. If it's not set up with a fraction, then that means give me the word that goes in there. So the word that is the reciprocal of the sine is cosecant. Okay, now turn it over. Here's another one. Just same kind of questions, just a little bit different questions. All right, so in that triangle, what is x?
2.
That would be 2. 30, 60, 90, the hypotenuse is a 2.
Is it 1, 2 square root of 3?
Yes. Which function is adjacent over opposite?
Cotangent.
That is your cotangent. That is your cotangent. SEC is the abbreviation for secant. That's the abbreviation for secant. All right, got another triangle.
Root 2.
What's that x?
Root 2.
Root 2. In your 45, 45, 90, your legs are 1 and your hypotenuse is root 2. Okay, now look at number 5. Look at where theta is. Think about what sine is. And what would be the answer?
12 over 13.
12 over 13 is exactly right. Because where that theta is, guys, right here, this is the opposite side. And this, of course, is the hypotenuse. So your sine, which is opposite over hypotenuse, would be 12/13. What function is the reciprocal of the cosecant? Sine. The reciprocal of the cosecant is sine. Tangent equals, that was the same question I didn't say. Maybe not, yeah. What's tangent? Opposite over adjacent, that would be one answer. Another answer would be y over x. And I've given quizzes before where I ask you for both of them, so you need to know both of them. All of the functions are defined 2 ways. You need to know both definitions. What is the abbreviation for cosine?
Cos.
COS. The abbreviation for cosine is COS. Guess which ones kids get confused? Cosine and cosecant. Cosine and cosecant. We get those confused sometimes. Let's not. All right. So, is it Monday I see you? So Monday we will have a quiz, one side. It'll be, you know, just like one page there, just like that, and you will fill it in. All right, let's get our notes out and let's start in on what we need to do in this big long trigonometry unit.
We haven't, so we won't have another test.
No, it would have to be next week. There's no way. Next week's our last week before exam. All right, so here we go. Change the following degree. Oh, by the way, it is really important that you take good notes. In Flex, I've seen some of the notes some of you take. You need to take really good notes because we're going to get partway through this, and then you're going to go away for 2 weeks, and then we're going to pick up right where we left off, okay? So don't not take notes because you won't remember this in 2 weeks, and I'm going to expect you to.
I have an idea.
Because we're going to pick up right where we left off.
Wait.
Can we do corrections for our quiz?
No,
I mean our test?
no.
Okay.
We're going to change the following degree measures into radian measures. Now, you maybe have absolutely no idea what I'm talking about when I say a radian. So let's talk about it. As you grow up as a mathematician, you are going to use degrees less and less. Right now, that's how all of your angles have been measured probably your whole life. You use degrees. Somebody said, how big is that angle? You say 12 degrees. The degree is a completely arbitrary unit. If I said to you, define a degree, what would you say? What's a degree? It's one way of measuring an angle, but it is literally defined as 1/360th of a revolution. Okay? So why isn't a degree 1/400th of a revolution, or 1/200th, or 100th, or something? Well, it has to do with the Greeks and the Egyptians and their fascination with the number 60. Somebody has 60 minutes in an hour and 60 seconds in a minute. They were kind of fascinated by 60s. But really, it's an arbitrary unit. So mathematicians have an angle measurement that actually has meaning. If I take a circle, and I'll just make up a radius, I'll say it has a radius of 5. If I lay a piece of string around this circle that is exactly radius length, so 5 units long. So here's an arc that's 5 units long, the same as the radius. These endpoints obviously create an angle, right? That angle is 1 radian. So a radian is produced by striking an arc of radius length. If you strike an arc or make an arc of radius length, that would be 1 radian. Now obviously, if I change the size of my circle, then to get 1 radian, I would need to do what? Have 10 units out here, right? Because a radius produces a radian, hence the word radian. Okay, it comes from radius. As you grow up, after this class, half of this class will be in radians, and half is still in degrees, but after this, it's all radians. Everything's radians, nobody uses degrees after this. So we gotta be able to move from one to the other as we're learning here. We gotta be able to convert from one to the other, much like you did in chemistry. And you know, converted from centimeters to inches and all that stuff. We need to be able to do that. So 100 degrees, we're going to change that into radians, and it is super simple, but I need to give you one more piece of information. If I went all the way around the circle, and I kept striking off, okay, so here's another 10, so there would be another radian, and here would be another radian, and so on. If I went all the way around the circle, 360 degrees, that would be 2 pi radians. So just like 12 inches is 1 foot, 2 pi radians is 360 degrees. Or we sometimes reduce that and say pi radians is 180 degrees. Divide both sides by 2.
So you said 180 that you add would be.
So pi radians, if I said spin pi radians, you would spin 180 degrees. They're equal. Pi radians is the same as 180 degrees. So if I want to know how many radians 100 degrees is, it's real simple. I know pi is the same as 180. This is 1. Pi radians is 180 degrees. So what is 100 degrees? I'll just set up a little proportion. If pi is 180, then what is 100? See how that works? Pi is 180. That never changes. That's a fact. Going to use it in every single problem. Pi is 180. What is 100? Well, what do I do? Cross multiply. So 100 pi equals 180x. And x equals 100 pi divided by 180. Which of course I will reduce, so those go out right away. And then I have 10 over 18, so the answer is 5 pi over 9. So 100 degrees is 5 pi over 9 radians. Negative 60 degrees. We're going to do it exactly the same way. So how are we going to start? How do we always start? Pi over 180. Pi and 180 are equal. What is equal to negative 60?
180x equals negative 60 pi.
So we'll cross multiply. Negative 60 pi equals 180x. Divide by 180. So x equals, okay, we can cross out the 60s again. Or I mean the zeros, I'm sorry, the zeros again. So what is that? Negative 1 pi over 3? 1/3 pi, or just pi over 3? That might make sense to you if you think about it for a minute, because if a whole pi is 180, does it make sense that 1/3 of a pi would be 60? Does that make sense to you? All right, one more, 210. See if you can figure out 210 on your own. You're gonna set it up exactly the same way.
But you'd equal it to 360? No. Or,
Okay, you're gonna do this exact thing. Only instead of 100, you have 210.
so it doesn't
You're
matter.
gonna do this exact thing. Only instead of 60, you have 210. When we want to change from degrees to radians, we set up our proportion. Pi is to 180 as something is to whatever angle it is. In this case, 210. First example, it was 100. Second example, it was negative 60. Now it's 210. So we cross multiply. And we'll divide.
This is overall, not what we're doing
Okay.
Alright, you guys see you, boy?
So what does x equal? What does x equal? You're supposed to be doing this on your own.
7 pi over 6.
7 pi over 6. That's exactly right. These zeros canceled out again, so we had 21 over 18, which we can reduce to 7 pi over 6. All right? So I want everybody to look at the 3 problems we just did.
Those are super easy.
They are. They're exactly the same, except there's a different number in this spot right here, depending on what the problem was, right? So look at the 3. Didn't we set them all up exactly the same? Set them all up exactly the same, right? That's how we do that time. Now, look at the next time. It's a little bit different. Now we're going the other direction. This can be even easier. Remember what I had written down here, but I erased it? I said pi radians is 180 degrees.
Yep.
So when you look at 2a, and it says pi over 4, that is pi radians.
So that's just 180.
It's 180 divided by 4. That's exactly right. It says take pi radians and divide it by 4. Well, if pi is 180, then I'm just going to divide 180 by 4. And that is 45 degrees. So pi over 4 is nothing more than 45. Look, this is fact. Divide both sides by 4. See how that works? Pi over 4 is 180 divided by 4.
So this one's 2 pi.
So is this
That'd be
360 over 3?
360.
Yeah.
So the next one is 2 pi over 3.
360.
It's 360 divided by 3 because it's 2 180s divided by 3. So that would be 120 degrees. Now, you're going to be doing a lot of these, so let me give you another way to think about it. That's perfectly fine. Perfectly fine. That was easy arithmetic. But sometimes this number gets a little bit big, and we don't want to, like, let's say it's an 11. We may not want to multiply 11 times 180 because that would be a big number. So do the division first. You know pi is 180. Let's divide that by 3. What do we get when we divide 180 by 3? 60. And then let's multiply it by 2, and that is 120. So sometimes it's easier to do the division part before you do the multiplication part. Does it make any difference? No. You'll get the right answer either way. Negative pi over 6. Negative pi over 6.
So negative 180 over pi over 6.
Yep. So the answer would be
30.
negative 30. Don't forget, you can't lose the negative. It would be negative 30. Here's one where it's probably easier to do the division first. 7 pi over 6. We all know that pi is 180, right? What is 180 divided by 6?
30.
30. What is 30 times 7? 210. If you did it the other way, you'd have to take 7 times 180 and divide by 6, and that's gonna take a long time.
Then we'll get a calculator.
You know what, you're not gonna have a calculator for part of this test, but this kind of thing, we're gonna be doing hundreds of times. So we kinda just wanna get good at it, because it's gonna take forever.
Is there a reason you put the degree sign next to the -30? I don't know that.
Oh, I should have.
I know there's a special
I'm lazy. No. Degree measures should always have the degree sign. That was the laziness on my part. Thank you for calling me on
I wasn't
it,
trying to.
James. This is fine. Okay, E. What is different about E?
It's not a lie.
There's no pi. So our strategy as we've gone through has been just to think of the pi as 180, right? If there is no pi, we have to go back and do it the way we did the ones at the top that didn't have a pi. Remember, the first problem says 100 degrees. There was no pi there. So I set up my proportion. So for problem 2E, I'll say pi over 180, because that's what I always say. Now be careful. What's on the other side? 2 over x. Very good, math. Why is it 2 over x? Because the pi is the radian and the 180 is the degree, right? So when I set my fraction up over here, I have to have a radian over a degree. What's the 2? Doesn't the direction say this is a radian measure? So the 2 is a radian, so he's got to go up on top. So now I'll cross multiply, so pi x equals 360. And I'll divide by pi, so x equals 360 over pi degrees.
What's your answer?
That's your answer.
So why wouldn't it just be 2 degrees?
Because this is a degree, not a radian. Pi, when it's a radian, is 180. But pi, when it's a degree, is 3.14. This is about 120. Yep. F, if you can't do F, we are in heap big trouble. Pi radians is how many degrees?
180.
180, that's an easy
75.
one. 180. All right, get your calculator out. Remember I told you the other day, you need to bring it every day. From now on, every day we're gonna have calculator work. Some calculator, some no calculator. You've gotta be able to do this. If you don't have one, sit up, Brittany. If you don't have one, try to lean over like you guys lean over. Seth's got one, Kate's got one. Use your calculator to convert the following into degrees, minutes, and seconds. How many of you have ever watched an old, like, war movie, and the submarine navigator or the airplane navigator has said something like latitude 28 degrees 11 minutes? Yeah. Circles are divided up into pieces called degrees, but the degrees can be broken down into smaller pieces called minutes, and the minutes can be broken down into smaller pieces called seconds, just like the clock, okay? So your calculator has the ability to change this, which is called a decimal degree. It can break that down into those subunits of minutes and seconds. Here's how it works. First of all, go to mode on your calculator, top row of buttons where it says mode. No, we want to be in degrees. So highlight degrees, because this is a degree measure. So highlight degrees. Maybe before, when you looked at modes, you didn't know what radian meant. Now you do, right? That's just another way of identifying angles. Okay, so we've highlighted degrees. Now, type in 100.4.
Where's the degree?
Press mode.
I know, I'm on
Look at all the lists of options you have, and one of them is degree.
Wait, so you click on degree?
Well, you just want to highlight it. You don't click on it, you highlight
Just
it
enter. Hit enter.
and hit enter. Yeah. It says degree. Now, we got 100.4, put that in. Got it?
Yeah.
Now, if you look at the apps button, which is right next to your math button, right above apps, do you see how it says angle?
Yeah.
So press second angle. Down in that list, do you see DMS?
Yeah.
That stands for degrees, minutes, seconds. So we go down, we hit that, hit enter, and then hit enter again. And it says this is 100 degrees, 24 minutes, and 0
Why
seconds.
is it 100 second wait?
Okay? So, do you know how on the clock, well, all you're doing is this, guys. On the clock, I can say to you that I am going to do math for 1.5 hours. That's a decimal, right? 1.5 hours. I can also say I'm going to do math for 1 hour and 30 minutes. Isn't that the same thing?
You can say it.
That's what we're doing here. So instead of saying 100.4 degrees, we're saying that's 100 degrees in 24 minutes. Just exactly the same as you do with the
So I'm
time.
gonna do 100 degrees.
All right, so the next one says 18.375. So we'll put in 18.375. Then we go to our angle menu, right? So second apps. Go down to DMS. What'd you come up with?
18, 22, 30.
18 degrees, 22 minutes, 30 seconds. Perfect. Negative 20.42. So we type in negative. Everybody knows where the negative button is on your calculator, down by the enter, down by the decimal point. Negative 20.42. Second apps. That's your angle menu. Down to DMS. What'd you come up with?
25 minutes, 12 seconds.
Okay, make sure you're using those little hash mark deals there to delineate
Degrees.
seconds and
Apostrophe,
minutes.
quotation.
Oh no!
Oh.
Look at the next section.
Oh no.
What do you think we're doing here?
Oh.
Same thing.
Well, except backwards.
Yeah.
Now we're starting with this, and we're gonna make it look like this.
Oh, I think I thought of that one.
Good news is, your calculator can do this for you, okay? So here's what I want you to do.
Is your first number always the? No, actually that's wrong.
So we're gonna type in 132. So just type in 132. Okay? Now, I want you to go back to your angle menu, so second apps, and you see the very first thing there is a degree mark.
Yeah.
Press enter, and now on your screen, you see 132 degrees, right?
Type in 11.
Now type in 11. Okay?
Like you press clear.
No,
No.
just type in 11.
No.
Then we go back to our angle menu,
So second.
and we go down one, because there's the minute mark. So now my calculator says 132 degrees, 11 minutes.
Yep.
Press enter. 132.18, repeating 3 degrees. There is your decimal for 132 degrees, 11 minutes.
Ah.
Okay? So, all of these problems, we go into our angle menu, right? And then just pick the degree symbol, the minute symbol, the DMS, whatever we need. All right, let's try the next one. 18, 12, 13. All right, so what do you think we do first?
Type in 18.
Type in 18. So we type in 18. As soon as we get 18 typed in, we have to stop and do what? We need to go into our angle menu and get the degree symbol. Right, it's the first one. Now what do we do?
So we get the other one.
Well, we put in 12,
Press second.
and then get back into your angle menu, second apps, and go down and get the minute mark. What was it, 12? 12 minutes. Okay, when it's time for you and Hugh to go, you just go. Remember that you're responsible for everything. All right, so now we got 1812 in there.
Yeah. What's second?
Now, I'm going to type 13. And I should have had you look when we were in the angle menu, but maybe you noticed yourself. Did you see there wasn't a seconds mark?
The R.
No.
No.
There's no seconds mark in the angle menu. So here's where you get it. Don't ask me why. This would be something you could Google. I have no idea why. This is so weird. Here's how you get your second mark. Look down your buttons here. Look at your plus sign. Your regular plus sign. Right above your plus sign, for me it's in green,
Yeah.
is my second mark. So I use alpha plus. To get the green marks, you have to use the alpha key. Okay?
Wait, oh, I missed
So we alpha plus, and then we press enter, and that one is 18.2036111 degrees.
So we type in all that?
Wait.
Well, you'll round it however you're told to round it. That's what you come up with.
Alright, so.
Now wait, let's try another one. Just stop. Let's try another one. There's one more. Here we go. So we're gonna put in, how do we start? Negative 152. Then second angle, right? Degrees. And then 18. What do we do after we put in the 18?
Alpha.
No.
No, it's not yet.
No.
Let's go to the
Second angle, and then down to the minutes. And then we put in our 39,
Alpha.
and then we alpha plus it, and we get negative 152.311 if I round it up. Okay? Everybody got it? Alright, so now we're going to go back, no calculator here for a minute, and we're going to look at number 5. Anytime you see this picture, think about arc length. Almost always, well certainly for us in this class, when we see that picture, we know we're going to talk about arc length. This is the arc length.
And that's the theta.
That's your central angle. And that's your radius. Now, I should have talked about it when I had my picture up here before, and I didn't. So let me go back to that for a minute. When the radius was 5, we said we could make 1 radian. I'll make that 1 radian. We said we could make 1 radian if this was also 5. But then we said, what if this was 10? Then that wouldn't be 1 radian anymore. What would that be?
2.
That would be 2 radians, right? Because every 5 gives you 1 radian,
Yeah.
and there's 2 5s there.
10.
So let's look at the relationship here between these numbers. When we had a 5 and a 1, that was a 5. When we had a 5 and a 2, that was a 10. Any guesses
5 times
if
2
we
is
had
10.
a 5 and a 4, what
20.
this would be?
20.
20.
5 times 4 is 4.
So you just kind of figured out that arc length is whatever the radius is times whatever the radian measure is. So if your radius was 5 and your angle was 2 radians, then your arc length was 10. So radius times radians will always give you arc length. Oh, that's easy. Let's look at number A, or letter A. It says, okay, our radius is 10, our angle is 2 radians. What is our arc length? 20. Easy, easy, easy. 20.
Yes.
Arc length is radius times radians. That's it. So, V.
1.5 R
We got
equals 6.
1.5, we got 6 out here. Watch it now, the arc length is 6, and now we want to know the radius.
1.5 R.
So I'm hearing somebody over here saying
1.5.
radius times radians equals arc length,
So you divide.
so we'll divide. And the radius equals 6 divided by 1.5, which is 4.
So we can't use a calculator for that part?
This will probably be no calculator.
Oh.
All right, come on, we gotta get these done. I don't know how much time we have left.
Like 15 minutes.
Oh, good.
We
All
got
right.
hugs today too.
Oh, darn, what a bummer.
No, I was like saying that's a good thing.
Okay. All right, so here we go.
Let's pray real quick.
Yes, because this afternoon I have my scan, so let's
Oh.
pray. Yes. This is the day the Lord has made, let us rejoice and be glad. All right, so this 10 is our arc length, our radius is 4, and our angle is our radius is 4, and our angle is unknown.
1Q equals
We
9.
don't care. The equation is going to be 10 equals 4 theta. So theta equals 10 over 4,
I don't know.
which you can write as 5 over 2 or 2.5, whatever you're comfortable with. So the angle is 2.5 radians. That's how big that angle is. It's 2.5 radians. All right, so I'm ready for D. Now, you guys, I must have been in a bad mood when I did D. There is something very wrong about D.
Agreed.
It's a degree.
That's not gonna stop us though.
And it's not gonna stop us, because we know what we're gonna have to do. We're gonna have to change that degree measure into a radian measure. Because in order to find arc length, we need radius times radians.
It's a big number.
And if we don't have the radians, we're gonna get the radians. So look back at the very first problem we did. How did we change 100 degrees into radians? What did we do?
Pi over 180.
Pi over 180 equals something over 30. Does everybody understand why I put the 30 on the bottom this time? That's a degree. 180 degrees, 30 degrees, they go on the bottom. So 180x equals 30 pi. So x equals 30 pi over 180. Let's reduce that because we don't want to work with that. Zeros will cancel. What is that? Pi over 6?
1/6.
1/6 pi or pi over 6.
Yeah.
You can say 1/6 or you can just say pi over 6. All right. Now we can do it, right? Arc length equals radius times radians. Remember, this is 10 over 1.
Do a little cross cancel.
straight across. So it's going to be 10 pi over 6, which is 5 pi over 3. So there is the answer to the question. Very good. That's as hard as they get. They don't get any harder than that. It's a two-step problem because first we had to change into the radians, right? Oh, shoot. Same thing here. I don't know the radius. I know my angle is 90 degrees, and I know my arc is 10 pi. So what do we need to do?
Set it up over
Pi over 180.
You might be able to do that one in your head. If 180 is a whole pi, what's 90? Half a pi? So if you can do that in your head, feel free to. I'll go ahead and set it up. Pi is to 180, as something is to 90. So x equals 90 pi over 180, which reduces to pi over 2, just like you said. Just think about that. Pi is 180 degrees. So wouldn't 90 be half a pi? Now we can do our formula.
Oh, or you do the other one in your head too.
Uh-huh, you sure can. Arc length equals radius times radians. And Zach, my hope is that as we do more and more of these, you'll be doing them in your head so that you don't have to write this out every time.
Yeah.
But that will take us practice.
Times by 2.
So we're going to times by 2. That's a great idea. That will get rid of that. So we have r pi equal to 20 pi. Then we'll just divide by pi. So r equals 20. Okay, we're going to do one more thing. We need our book. Does anybody have a book? Everybody have a book? Do you have any books? On your iPad? That's fine. We're on page 357 in the book. I don't know if it's the same on the iPad. Section 4.1.
357?
357. And you see a compass there? Look at Sam there with his book.
Put some notes in there already.
Okay, so we try to look at a book. This won't make any sense to you if you're not looking at the picture. The question that I've asked on the page says, using the compass, find the angle measure that describes the following directions. E, S, E. Now, anybody have any idea this is a compass? What do you think the E and the S stand for?
Southeast.
East, southeast. So those of you that aren't Boy Scouts, let's look at a compass here. This is north, this is south, this is east, this is west. Right? And that's a 90-degree angle right there. If I draw a line right smack dab in the middle, that would be called northeast. If I draw a line and split this one is called northeast because it is on the north side of the northeast line. If I draw on this one, it is east-northeast because it is on the east side of the northeast line. Now, I'm only looking at this quadrant. Remember, the whole shebang was 90, right? So when I did this one, that one was 45, split it, right? Then this one, well, let me do it this way. This whole angle was 45. So these are going to be 22 and a half. Would you agree with me?
Yes.
And you're going to be able to do that in every single quadrant. So let me just randomly do another one. This line would be what? Northwest. What would this line be? West northwest. Very good. It's on the west side. See, northwest has two, I can split two of these. If I do this one, I'm on the west side of northwest. If I do this one, I'm on the north side of northwest. So this one would be northwest. And all these angles are 22 and a half. Okay, so which one am I looking for?
East, southeast.
East, southeast.
So
Of
the
course,
top
one that I
quadrant
don't
of
have,
southeast.
one that I don't have drawn.
That's 112.
East, southeast. This would be southeast. And then this would be east, southeast. Would everybody agree with me?
Yes.
And this little angle here is 22 and a half, just like all the rest of them. When we use a compass, due north is 0. Due east is 90, south is 180, and west is 270. That's the way a compass is set up. The rest of mathematics is not set up that way. But when you're dealing with a compass, due north is 0. So if I want to get to east, southeast, which would be right here, how many degrees do I need to go through? Well, I need to go through 90, right? And then an extra 22 and a half. So what is that? 112.5. So east, southeast is 112.5. Now, what about southwest?
220.
Well, here's southwest, right? Again, you're starting up here and you're going this way. Well, if you go all the way from north to south, that would be 180.
Yes.
And then how much is this? Be careful, it's not split. This whole thing is 45. So 180 and 45 would be 225.
Yeah.
So the directional heading for southwest is 225. So when a pilot says, I'm going to fly on a course of 225 degrees, that's what he means. He's going due southwest.
So if anyone's gonna be a pilot,
West, northwest.
292.5.
West, northwest, I already have, right? So think about it. You're coming all the way around to west, which is how many degrees if I'm going all the way from
270.
north to west? 270? And then an extra 22 and a half?
So that'd be 292.5.
292.5. You're exactly right. And then the last one, north, northwest.
337.5.
North, northwest is right here. Now some of you might want to cheat and say, oh, let's just do this. You can't. When we measure navigationally, it's this way, all the way around. So north, northwest would be, oh my gosh, pretty big.
337.5.
337.5. All the way around 360, except for this little bit right here, right?
Yes.
So 360 minus 22 and a half. Oh, we're not done. We got one more. One more game.
What time's class over? 20?
Yes. A ship leaves port and travels 15 miles on a course of 100 degrees. You're going to draw a picture of this. So here's your compass. He's traveling on a course of 100 degrees. Now remember, you start here and you go this way. So wouldn't 100 degrees kind of look like this? Would you agree?
Yep.
And he goes 15 miles. So I'm going to label that 15. That vector I just drew is 15 miles long. Then he changes course. So I'm gonna put another compass right here. So he's sitting right here now. And he's gonna go on a course of 200 degrees. Now you're starting here, so you're starting all over again. So this would be 180, right? So 200 is gonna be over here like this. Wouldn't this angle here be 200?
Yeah.
And he goes 2 miles. So that one's 2 miles long. Draw a sketch of this journey.
Easy.
Done. Now, you're thinking to yourself, okay, that was okay, but what now? Well, as we go through the chapter, we'll answer this question. He sinks. The rescue plane is back at port.
No.
Your job is to send the rescue plane to get this guy. So what do you need to know? What heading does he need to go on
Fastest way
to
to get
get
there.
to it? Exactly.
Go.
Because if he's out there drowning, you want to get there as fast as you
Do we need more
can.
projects? That makes sense. Hey, Sword, we need to do more of those.